Okay, today we're going to take a look at some log laws, some things we can use to simplify expressions. Just like we could with exponential functions, make things easier with before we actually had to calculate them. For example, 2 to the 5 times 2 to the 7 over 2 to the 3 like this one here. We can make that 2 to the 12 on top over 2 to the 3 by adding our exponents. And then we could subtract our exponents and say that's 2 to the 9. That'd be a lot easier to work with than this messy expression. And like we can do there, we can do the same things with logarithms. Okay, so there's 3 rules we can apply today that will help us when I cannot calculate a logarithm evenly. And by that I mean a whole number. So for example, if I had log 2 to the power, log base 2 of, I don't know, 6. Well, I can't figure out 2 to the power of anything. Doesn't make 6. There's nothing I can think of a nice whole number. So maybe there's something else I can do to simplify this before I try calculating it. So 3 rules for you. Okay, and all of these rules, the first 2 rules, the base has to be the same. Remember, with base, we mean the little small number down here, right? So rule number 1, the product rule. If I have 2 logarithms that are being added together with the same base, a simplification of that is to multiply the 2 values together and then take the log. Okay, so for instance, if I had log 2, 3 plus log 2, 4, I can write that as log 2 of 3 times 4, or in other words, log 2 of 12. Maybe that's something I can do. Okay. The opposite direction, if I have logarithms that are subtracting, again the same base, I could turn that into dividing. Okay, so if I had log 2 of, 12 minus log 2 of 4, I could turn that into log 2 of 12 over 4, or in other words, the log 2 of 3. And again, maybe that's something I can calculate easier. Now, these are just made up examples. These aren't things we've calculated yet. We'll go through some in a minute where we can do that. Okay. The third rule is if I have a value to an exponent, we're going to call this the power rule. So I have some value and it's got its own exponent on it. I can take that exponent and bring it down and put it in front of the logarithm, okay, which is what this shows over here. So for example, if I had log 2 of 3 to the power of 4, I could turn that into 4 times the log 2 of 3. And depending on the kind of question it has, maybe simplifying will help us evaluate things. Or maybe, in some cases, unsimplifying will allow us to calculate things. The big idea here is we have to work back and forth. Okay, so those are your 3 rules. Logs adding, you can multiply. Log subtracting, you can divide. And log of something to an exponent, the exponent comes down in front. Okay, so we'll try a few right here and see how this works. Okay, we're going to simplify then evaluate. Now, if I were to try calculating this, 6 to the power of something equals 4, there's nothing at all that I could possibly think of 6 to the power of something makes 4. It wouldn't be good to try and evaluate this the way it is. But if I were to take these 2 logs, and notice they have the same base, which is log 6, and say, hey, these logarithms are adding, that means I can multiply their 2 values together. And if I do that, 4 times 9 makes 36. Well, now I can think to myself, 6 to the power of what makes 36? Well, 6 to the power of 2 makes 36. So I know that that is equal to 2. And I couldn't do the parts individually, but once I put them together, I could. Okay, let's try the next one. 2 to the power of something make 18. Nope, can't do it. But I notice these 2 things have the same base and they're subtracting, which means I can do 18 over 9. And the order matters. The first one's going to go on top. And then take, 18 divided by 9 is 2. Think to myself, 2 to the power of what makes 2? Well, 2 to the 1, obviously. So the answer to that question is just 1. And I couldn't do it at the beginning, but I can do it in the end because I can put them together. Okay, so those are sort of the first 2 rules. Third one, obviously rule number 3 here, right? I see a logarithm to an exponent. Well, rule number 3 is I can take the exponent, the part up here, and put it down in front. So I end up with 2 log 3 of 9. Well, what is log 3 of 9? 3 to the power of what makes 9? Well, 3 to the power 2 makes 9, right? So this piece here is 2. Now I still need the 2 from the beginning, so really it's 2 times 2, or in other words, 4. Okay. I can try D here. Root signs. We don't like root signs. Let's get rid of the root signs if we can. Another way of writing this is log base 2 of 8. A root sign of a, that means the exponent of a half, right? Oh, a log to a power. Where can that power go? Down in front. Then we think to ourselves, 2 to the power what makes 8? 2 to the 2, 2 to the 2 to the 3 works. Okay, so this piece here is worth 3. I got the 1/2 in front still. Half of 3, 1.5. Yeah, I couldn't have calculated in the first place, but I could after I simplified things. Okay, we got one more here, letter E. We'll give it a try. Let's drag it down here. Okay, root signs again. We like those root signs. Hey, what can we do with those? Well, we know that a fourth with a 4 out front makes it into a fourth, right? I can't do 27 to the fourth. That doesn't work. But I put the fourth down front, and then think to myself, 3 to the power what makes 27? Oh, I know what that is. That's 3. I got the 1/4 in front, so they're multiplying, and I get 3/4. Okay, that's so we can use log laws a little bit. Now, sometimes we want to work backwards and work with things. Okay, so let's use the properties of logarithms to take this equation and represent it in terms of 3 separate logarithms. Okay, all base 4. So, what can I do with that? Well, I recognize on the top, I've got things that are multiplying, which means I can re-separate them into things that are actually being added, right? And I've got a dividing on the bottom, which means I can turn that into a subtracting. And those would be 3 separate logarithms. Now, it didn't say it wants log 4x to the power of something, so what can I do with that power, this 3 right here? Well, one of my other log laws is I can put it down in front. And same thing with this one. I can put the 2 down in front, and this one I don't need to worry about because it is just log 4 of z. And there you go. There's a logarithm that's been re-expanded. Okay, so we work forwards, we can work backwards. Okay, a couple more, slightly more challenging ones. Okay, what can we do with this? Can I figure out 3 to the power of something makes 36? 3 to the 2, 3 to the 3, 3 to the 4, none of those work, right? So I need to change its form. What can I do with this? Well, I know that I can move the half. I can move the half back up top. Okay, I then want to think to myself, okay, log 3 of 27. Is there anything I can do with that? That number, that's something I can do. 3 to the power of 3 makes 27. So I can do that just into the number 3 if I wanted to. This piece right here. Is there anything I can do with log 3 of 2? 3 to the power of anything make 2? No, I don't think so. So I'm going to leave that part alone. Okay, what can I do next? How can I simplify this? 36 to the half. Well, isn't that the same thing as saying the square root of 36? Yeah, 3 is 3. I can't really do anything with this. What's the square root of 36? That would be 6. So I made that a little bit easier to work with. I got the 3 here. I got the log 3. I can't do anything with these numbers right now, right? Okay, I like the number 3. That's a good number. But the 2 logs, I got a bit of a problem here. Maybe I can combine those 2 things together. If I were to think of this in a different order, and we're allowed to move orders, right? As long as we don't change signs or change values, order doesn't really matter. Hopefully you guys would agree that's the exact same equation. I just moved the log 3 here and put it in front, right? Well, then I noticed that I got these 2 logs that are subtracting. Well, maybe I can turn that into dividing. And if I do that, 6 divided by 2 makes 3. 3 to the power of what makes 3? Well, 3 to the power of 1 makes 3, so I ended up with 1 plus 3 is 4. Okay, so that one I had to go back and forth and try and use my log laws to evaluate without actually having used a calculator. Okay, and I can't use the calculator because these aren't base 10s, right? Let's try the next one. 8 to the power of something makes 2. No. or the next one. And 8 to the power of something definitely doesn't make 16. So I need to change these forms somewhat. Now I notice I got some numbers in front of logs, so let's fix that first. 8 squared. Log 8 2 to the 3. Log 8 16 to the half. And let's try using those exponents, make them a little bit easier to work with. That one stayed the same. 2 to the power of 3 makes 8. 16 to the power of a half, we know power of half is like square rooting, makes 4. Okay, I've got 3 logs that are all going together. What can I do with those numbers? I know that I can multiply 2 times 8 times 4. And if I do that, 2 times 8 is 16, 16 times 4 makes 64. Can I think of 8 to the power of something being 64? Sure I can. 8 squared is 64. So that is 2. Okay, just by playing with our logarithms a little bit and using our rules sort of go forwards and backwards, sometimes one format's helpful, sometimes a different format's helpful. We've got to be comfortable going to both formats. Okay, now these ones I don't want to calculate, I just want to write as a single logarithm. So I got to change their forms again. All right, what can we do here? I got numbers in front. Let's put them up top. Numbers in front. Let's put them up top. Okay, let's get rid of those exponents. 8 squared makes 64. 2 to the power of 5 makes 32. Okay. I got subtracting. That means I can rewrite this as dividing. Okay, and 64 divided by 32 makes 2. Hey, I got 1 log now. That's all I wanted. I don't care what the answers. I can't actually calculate that one, but I want 1 log. All right, we're going to do the next one. And if you need to pause and try and skip ahead and try some yourselves. What do I see here? All 3 bases are the same. What can I do? I got adding logs, so I can multiply them. I've also got a subtracting log, which means I can divide it. And I can do all those at one time. Oh, that turned into, 12 times 2 is 24. So 24 over 6, which means I get the log 3 of 4. Again, a single log. And I don't care what the answers. I can't calculate these. I'm just trying to write them as single logarithms. Okay, and that takes us to the end of logs. And we're not going to do too much of these log laws, just the fact that they exist. We can use them a little bit to simplify things. The most important one for us is the exponent idea, because we're going to use that to solve for some things. So you should be sort of comfortable with going forwards and backwards with the exponent one, which is rule number 3. Okay, there is a little quiz tonight you guys are going to try. It involves stuff from yesterday's lesson about just evaluating logs and 1 or 2 of these little log things. Okay.